So in this video we're going to be adding and subtracting some fractions that we were working with, in fact, in the previous video on comparing fractions. So I'm going to start with this one, 5/7 subtract 2/3. Okay, well, I can immediately see that I'm going to need to increase these numbers here so that I get a common denominator of 21. So 3 times 7 is 21, and I can't think of a number which is smaller than that that's going to work. We need to convert these sevenths and these thirds to 21sts so that we're actually able to add or subtract them. So let's write this out in full so it's clear what we're doing. If we multiply this side by the 3, so cross multiplying here, we'll end up with 3 times 5 over 3 times 7. And on the other side of the subtraction sign, we're going to end up with 7 times 2 divided by 7 times 3. So nice and straightforward. We haven't changed the fractions yet, we've just rewritten them to make things a little easier for ourselves. And if we multiply this out, we're going to, at the top here, we're going to get 15, so 3 times 5 is 15. Subtract 7 times 2 is 14, and here we're going to get 21, and 21 over here, 7 times 3 is 21 as well. So we've got a common denominator, so we can write it all together now, of 21. So we've got 15 subtract 14 gives us 1 divided by 21. So 1/21 is the answer. Now, if you're not sure about what I did there, the cross multiplication method, do go back to the comparing fractions video and see more examples there of how that works out. Okay, but let's move on and have a look at the next example. So we've got 10/14 and 15/21. Now, whereas in this example I decided I was going to increase the numbers to make life easier for myself, here I'm going to decrease the numbers because I can see that these fractions simplify. So in other words, I can divide this one by 2 and this one by 2, which we could write as 10 divided by 2, because 10 divided by 2 divided by 14 divided by 2, and that's okay, but it's a bit messy because I've got two division symbols here. I've got a divide by here and a divide here. It's mixing my symbols, and I think there's a better way of thinking about this, so I'm just going to erase that for the moment. So it's exactly the same thing really, but what I'm going to talk about is factors. So 10 has the factors, apart from 1 in itself, of 2 and 5, so I can rewrite that 2 times 5. And I know that I'm going to get one of the factors the same here because I said I could halve it, so I'm going to have 2 times 7 there as the factors of 14, apart from 1 in itself. So I've got 2 times 5 divided by 2 times 7 is the same as 10 divided by 14. All I've done is I've brought these down, both the numerator and the denominator. So I'm going to do the same to the other number here. So I've got 15, well, the factors of 15, 3 times 5, and factors of 21, 3 times 7. So again, I've got a common factor of 3. And that's very nice because it means I can cancel the 2's here, because 2 divided by 2 equals 1. And 3 divided by 3, I can cancel the 3's here, because again 3 divided by 3 is 1, leaving me with 5/7 here, plus 5/7, which is 10/7. Okay? Now, one last thing that makes me think about what I will do with this next problem actually is I can leave this like this as an improper fraction, perfectly okay, but it's tempting with something as simple as this simply to divide it out. So I'm going to divide it out. So I've got 10 divided by 7, 1 and 3/7. Okay, so whole number and a fraction, a mixed number. Right, as I say, that makes me think about the next problem, because looking at it, I've got improper fractions just as I had here, and what I might want to do is just change those straight away to mixed numbers. Let's do that and see if that works. Okay, so we've got 7 divided by 3 is 2 and 1/3. And we've got 12 divided by 5, 2 and 2/5. And that's quite helpful, I think, to work out at this stage, because I've got nice simple numbers here. I can rewrite them if I want. 2 plus 1/3 plus 2 plus 2/5, which means I can then commute. So I've got 4, 2 plus 2 is 4, plus 1/3 plus 2/5. Okay? And now all I've got to do is add 1/3 and 2/5. So I've got 4 plus a common denominator of 15. Okay? So I'm going to multiply, I'm going to cross multiply again. So I've got 5 times 1 is 5. 5 times 3 is 15. 3 times 2 is 6. 3 times 5 is 15. Now I've got the same thing, I've got 15ths here, so I can rewrite that. 4 and 5, sorry, let's put the plus in, 5 plus 6, jumping ahead there a bit too quickly. Oops, let's just get that right. Okay, so 5 plus 6 over 15. I can bracket that if you like, make it easier to see. There we go, that's just a plus sign. And now we've got our answer, 4 and 11/15. Now, before I move on to the final problem, just quickly, was it worth doing that? Was it a good method to convert these to mixed numbers and then work it out? What if we did it the same way as we did it here? It's always worth looking at alternatives. So I'm going to have another go. Let's just do a line under here. So cross multiply, I'll end up with 5 times 7, 5 times 3, plus cross multiply this side, 3 times 12 and 3 times 5, and what have we got? 35 plus 36 divided by 15 gives us, well, this is where it gets a bit tricky, because I'll end up with a really big improper fraction, 71 divided by 15. And now we do have to actually do the division, so I've got the challenge of dividing 71 by 15. It's fairly easy to do. I can chunk it up if I think of 4 times 15, which is something I can do easily. I just double and double again. Then I've got 60. If I tried 5 times 150 is like 10 times 150 divided by 2, so that would be 75. So that would be too much. So I do know it's 5. Sorry, I do know it's 4. And so then I can simply say, well, 4 times 15 is 60, and 71 subtract 60 gives me 11. So 11/15. So it's up to you. There are 2 ways of thinking about that. Neither one is right or wrong, and both, I think, work reasonably well. Okay, let's finish then with these rather larger numbers. Now, larger numbers shouldn't present us with any great difficulty, so we don't have to worry just because the numbers get quite big and complicated looking. Let's just work it through and we should get the right answer. So in this case, I think there are 2 sorts of things I could do. I'm going to just go off to one side to think laterally just for a second. In the last video we did talk about converting to decimals, and I think we had something like, well, we knew that 33 divided by 100 is obviously 0.33, so 3/10 and 3/100, or 33/100 is 33 divided by 100. So that should be clear. That decimal is very straightforward. 23 divided by 67 without a calculator is difficult. It's certainly possible, but it will take a fair bit of time. We could do it to several decimal places. I've just worked it out here to 3 decimal places. And so in the last video we found it went to that, and I've just divided a bit more to get 3 decimal places. We've got then 0.343 subtract 0.33. We can place one above the other to get our place value advantages. And let's just work from right to left here. 0 from 3 gives us 3. 3 from 4 gives us 1. And then 0, 0. So we've got 0.013 ... because we know that this number was incomplete, that those figures continued. So what we're going to have to say here is that all we've got is 2 decimal places of accuracy, because we can only say that this equals 0.01, and then this rounds down to that 1 to 2 decimal places accuracy. So I suppose if I'd have found a larger, if I'd worked harder on this decimal and got further into the decimal, I would have been able to say something more accurate, but it's likely that I never would have got an exact answer to this problem. So going back to the fractions and just using our usual methods and keeping it as a fraction, can we do any better than converting it to decimals? Well, looking at it, well, nothing does simplify, so we're just going to have to use the cross multiplication method. But it shouldn't be too difficult because we've got 100 here, which looks fairly straightforward. So let's start it off anyway. We've got 100 times 23 is going to give us 2300, and we've got, in fact, we can continue that fraction bar here. We've got 67 times 100 now. So that's 6700 is going to be our common denominator. So now, here we've got to do 67 times 33. We've already done 67 times 100. So the only thing to work out is what number we're going to subtract from 2300 here. Okay, so 67 times 33. I'm going to write that, let's go down here again. 67 times 33. I'm going to write that and use the standard algorithm. So we'll go from right to left. We'll put our placeholder in. 3 7s 21. Carry the 2. 3 6s are 18. Add the 2 gives us 20. And nice and easy. No placeholder this time. We're just in the ones column. So we've got 3 times 7, 21. Carry the 2. 3 times 6, 18 again. 20. So exactly the same numbers here, and very easy to add up, 2,211. So just move to one side to do my calculation there. Now I can take that number and subtract it from 2,300. That's going to give me, if I make my numbers a bit simpler here, 300 subtract 211. Okay. Might want to rewrite that again. So we've got 100 subtract 11 over 6, 700 gives us 89 over 6, 700. So that's my exact answer. That was my approximation, if you like, or my estimation, accurate to 2 decimal places. And I hope that shows that, even when we've got fairly large numbers, it's not that difficult to work out the answer. So just to finish this, we're going to look at the idea of the common denominator. This is when you have to join the two numbers by finding a common multiple, in fact, of the two numbers at the bottom of both fractions. So in this case, what I'm going to do is create two fractions. Let's have 3/4. So we're going to take 3/4 of this whole number here, and we'll have 4/5 of this one. And I'm immediately then going to divide the top one into 4 equal areas. So those are the 4 parts of our fraction. We're going to take 3 of those to make our 3/4. And we could divide it vertically like this, or we could divide it horizontally. As long as we've got 4 equal parts, then it's just the same. So with the bottom one here, I'm going to divide that then into fifths. And we can see that the common multiple, the lowest common multiple of 4 and 5 is going to be 20. So we're going to end up with 20ths. So how do we do that? Well, if we cross multiply, which is what we've been doing before, we're going to get our answer. So we take 5, so we take the 5 here, and we divide this up so that we end up with 20ths. In other words, we've got a 4 by 20 grid. Okay? And if we do the same to the bottom one, we're going to take our 4 division and multiply that by the 5 so that we end up with 4 times 5, 20 again. So there we have our common denominator of 20. Now we've just got to take our parts off so that we end up with 3/4 and 4/5. So now if we think of this as part of the original, then we've now only got 3/4 of what we had originally. In fact, let's just put that on the top there. So now we've got 3/4 of the number that we had originally, and at the bottom we've got 4/5 of that same size. So we can immediately start adding these together. It's only when they're exactly the same size of brick or tile, if you like here, that we can think of combining them or subtracting one from the other. Okay, so now what we want to do is some addition. And addition is finding the sum. So all it means is adding these two together, which we can do now that we've made them into 20ths. So 3/4 has become, well, we multiply by 5 here, so we multiply the top by 5, 15 20ths. And we've got 4/5 has become, so we multiply by 4 this time, 4 times 4, 16 20ths. So let's just check that. I do apologize. Let's just check that on our diagram. So we've got, we should have 15 here. So we've got 1, 2, 3 times 4 gives us 12 here, plus the 3 on the top gives us our 15. And here we've got a 4 by 4 grid. So we've got 4 times 4, 16 20ths. So that's fine, and if we add them together, we're obviously going to get 15 20ths plus 16 20ths, giving us 31 20ths. Alright, so that's addition. Let's now have a go at subtraction. And what exactly do we mean by subtraction? It's about finding the difference this time between those two numbers. Now this can be a little bit confusing because it's a little bit more than just finding the difference. Let's, for example, start with our purple, 15 20ths, subtract our 16 20ths, and we're going to get here clearly minus 1 20th. So what does that mean in terms of this diagram here? Well, if we start with this number here, here's our 15 20ths. And let's say we have to pay somebody 16 20ths. So we've got to lose all of these, and an additional one. Let's say this person, let's say we are A, and this person is B. So B says we owe them 16 of these little tiles here, 16/20ths. And A says, well, I've only got 15, but I'll have a go. So we cross off 4 of them, give this person 4, and he ticks off that he's received 4 of those. We give him 4 more, and he ticks off 4 that we don't owe him anymore. We give him this row here, and again he ticks off. But he says we still owe him 4. We've only got 3 left. We are now down to 0 of our little tiles here, of our 20ths. But he's only been able to tick off 3 of them, so he says you still owe me 1 tile, which means we have to record that we now have not just 0 but -1 tile.